Since I know it's going to cross there, I'm actually going to walk that way. All right, so you're saying my red dot was wrong. I probably counted wrong. So we'll do this one. Then we'll do this one. -3, that's right. Oh, I counted 4 up. I should have gone up to here. There we go, and over 7. That works. 1, 2, 3, 6. There we go. Yeah. So double count, by the way, just in case. I will say I am always going to give you for these, it will always be integers for these. So if for some reason you land somewhere else, you may want to do what I just did and say, for some reason I'm not walking onto that line. So once you see where they cross, which like I said, it should be at a perfect point right here, then you're going to say, okay, this here, that is -7. This is +3. So my answer is -7, +3. The second type you're going to have is like number 5. These are not in slope-intercept form. So I would recommend putting them in slope-intercept form. So for the first one, I'm going to move the 14x over. I have -3y equals -14x plus 18. And then I am going to divide everything by -3. So I get y equals 14/3 x minus 6. I'm going to do the same thing with this one. Move my 14x over. -3y equals -14x minus 12, and then divide everything by -3. What do you automatically notice about these two? They have the same slope. So this is going to be a special case, but because your instructions tell you to solve by graphing, you do need to solve by graphing. So you do need to graph those two lines and then tell me the answer. So if I start at -6 and I go up 14 and then right 3, I'm going to get my first line. And what's going to happen with this second line is I'm going to start at +4. I can't go up 14 here. So if I go down 14 and then left 3, 2 negatives will also give me that positive slope. And you should see something like this, parallel lines. So in a graph, parallel lines mean the same thing as what this is telling you, that you have no solution, and this is your answer. I need to actually have you tell me that you have no solution, or the lines don't cross, so there's no answer, okay? You can write out the words no solution if you don't remember that little circle with the slash, but I need you to tell me that that's no solution there. The first way that you can have substitution is you can have one variable that is already solved. In this case, you can see that that y is already solved in the first equation. So what I'm going to do is I'm going to take the other side and plug that in for y to my second equation. So I'm going to rewrite the second equation. I'm going to say -7x minus 7 times y. And instead of y, I'm going to write what y equals from the prior equation. And then I'm going to finish it equals -14. Then I'm just going to solve. So -7x stays there. I'm distributing a -7. So -7 and -5x, -7 and +10, and that equals -14. Then I am going to combine my like terms. I get -7 and 35. That's going to give me 28x minus 70 equals -14. Add my 70 to both sides. 28x equals 56. Divide x equals 2. All right, so I've solved for part of my answer. I know that 2 is my x value. I need to take that and I need to plug it in to one of my equations. And so you can go back to this and say, well, if I know x, what is y? Y is going to be what happens when I plug in X. Y is 0, which is a valid answer. 0 is a number, 0 can be an answer. 2, 0 is your answer there. The next type is where potentially both equations have a variable solved. And so when that happens, you're really just taking that and plugging it in. You're setting these two equal to each other. So if you have the same variable solved, like you have right here, then you're just going to say, well, that means that 6x minus 15 equals 4x minus 11. And so then I'm going to get my variables to one side. So I'll move my 4x over. I'll get my numbers to the other side. Move my 15 over to the other side. So my numbers should cancel on one side. My variables should cancel on the other. And I'm going to get 2x equals 4. Finish that out, x equals 2. So once again, I have the x portion of it. To solve for y, I'm just going to plug it back into either equation. It does not matter. So I would say y equals 6 times 2 minus 15. 12 minus 15 equals negative 3. That is my y value here. 2, negative 3 is my answer. The last type of substitution is that none of your variables are solved. And so when none of your variables are by themselves, I'm going to look at all 4 of these and say which one is the easiest to get by itself, okay? The easiest to get by itself is this y right here, okay? And so I am going to get the y by itself by moving that 2x over. So this will now be y equals 2x minus 15. I don't have to solve for y. If x is easier to solve for x. It doesn't matter which one you get by itself. And then I'm going to take that and plug it into my other equation. Plug it into my other equation. All right? And so I am going to say 4 times x plus 8 times my y, which is what I solved for up here, equals negative 20. All right? For those of you that like shortcuts, pay attention. For those of you that don't want a shortcut, don't pay attention. But I could do something with this before I plugged it in. What do you think I can do with that before I plug it in? Yeah, I can divide everything by a common multiple. I can actually go higher than that, can I? What goes in? Yeah. So if you want to, if you can reduce something all the way out, like as long as you can divide everything by that number, you haven't changed the fraction. I mean, you haven't changed the equation. I divided both sides by the same number. Doesn't that keep it equal, right? Whatever you do to one side, you do to the other. And so this equation could actually be written like this: x plus 2y equals negative 5. And I could plug it in there, and I will get the same exact answer. I will just have to deal with smaller numbers if I do, right? So instead of multiplying 8 by 15, I'm going to multiply 2 by 15, right, when I plug that in. So you are welcome to simplify an equation before you plug it in. All right. Oops, and that's going to be a 2. Make sure when you rewrite it, you write it correctly. So that you can make your numbers smaller, right? It's all the same. You can do it either way. So if you're comfortable reducing, if you're comfortable with this process, you can do it. If not, you can go straight to the original. No matter what you do, when you solve this, you're going to have to distribute, whether you distribute here or distribute here. Combine your like terms. Add over. So in this case, I'm going to add my 30 over to the other side. Negative 5 and positive 30 give me 25. So x equals 5. I know my x value here. To get my y, plug it back in. So go back, plug it in. And I would say negative 2 times 5 plus y equals negative 15. Negative 10 added over, y equals negative 5. And so you can do it. Either of these are going to give you the same answer. This one is just going to start with bigger numbers. So I'm going to have 4x, 16, and 120, right, equals negative 20. And then I'm going to have much larger numbers to deal with. But it'll still work out. Division will be a lot more difficult because you'll have larger numbers. Elimination is often called addition because what you're doing is you're adding the two equations. However, before you add, you have to make sure that one of your variables will eliminate or it doesn't help you, okay? So the first thing I'm going to do is I'm going to say, if I were to add these, would one of my variables eliminate? Yes, I have a positive 1 and a negative 1. Those will eliminate if I add them. So for this one, I'm ready to go. I can go straight to the addition piece of it. And I can just say, well, just add these. Positive 1 and negative 1 cancel. Negative 2 and negative 1 give me a negative 3. Y. 18 and 12 give me a positive 30. And then I can just divide both sides by negative 3. And I have that y equals negative 10. So in this case, I know the y value. To find my x value, plug it into either equation. X minus 2 times negative 10 equals 18. X, negative 2 and negative 10 are positive 20. Subtract your 20, and you have your second variable there. So you have your answer, negative 2, negative 10. That's the first one that you could potentially have, where you can just go straight to the addition, right? Straight to the addition. The next one that you could have is like number 23, where one of the variables is easier and you really only have to multiply one equation to eliminate. And there's actually two ways to do this one. So I have negative 4x and positive 2x. If I add those, they will not eliminate. That would actually give me negative 2. Negative 2 and negative 2 also will not eliminate. That would give me negative 4, okay? So there's a couple things you can do. You could divide this guy by 2. That would give you a negative 2 and a positive 2. You could multiply this guy by 2. That would give you a negative 4 and a positive 4. Or you could multiply either equation by negative 1 and your y's will cancel, right? And so there's a multitude of ways to do this that will give you the same exact answer every time, okay? It does not matter which. So I'm just going to multiply by negative 1. So let's say I want to multiply this guy by negative 1. All right? What that's going to do is that's going to give me a negative 2x, a positive 2y, and a negative 14. Now, if you do it like that, where you just write it below, make sure you tell yourself you're not looking at that one at all, okay? Just don't make easy mistakes. And so for this one, I would say we have a negative x. So I'm going to add these two. My negative 2y and my positive 2y cancel. And positive 14 and negative 14 is 0. If I divide this guy out, 0 divided by anything is just 0. And so I have my x value here. To get my y value, go back and plug it in. 2x minus, well, we'll go ahead and plug it in. 2 times 0 minus 2 times y equals 14 was this equation originally. So that zeroes out. Negative 2y equals 14. Divide by negative 2, y equals negative 7. So now I know my y value here. 0, negative 7. And then if you look at 29, the first thing I'm going to check is, will any of the variables cancel? Well, no, because negative 3 and positive 2 is negative 1. Negative 5 and positive 8 is a positive 3. Nothing will cancel. nor can I just multiply one of them. So it's not like these are multiples of each other or just opposites of each other. Like it's not that simple, okay? Which means I'm going to have to multiply both equations. So I'm going to pick the smaller ones, right? Like I could get 8 and 5 to a common multiple, but it's going to be a much larger common multiple. So I would probably choose the 2 and the 3, and I would multiply those to get it to the least common multiple. What is the least common multiple between 2 and 3? 6. One has to be negative and one has to be positive, and in this case, I already have that. So I literally just have to multiply to get it to the 6. I'll multiply the top then by what number? 2. And I'll multiply the bottom then by 3. Now I have to multiply every piece. So 2 times negative 3x, 2 times negative 5y, and 2 times 23. And I have to do the same thing with that 3. 3 times 2x, 3 times 8, and 3 times negative 20. All right. And now I'm ready to add because I have a positive and negative. My negative 6 and positive 6 are going to cancel. My negative 10 and positive 24 give me a positive 14. And my 46 and negative 60 give me a negative 14. And then just divide that out. Y equals negative 1. Once you know the y, plug it back in to either one. 2x plus 8 times negative 1 equals negative 20. We get negative 8 here, so add it over. 2x equals negative 12. Divide by 2, x equals negative 6. So I know my x value as well. This first type, whether it's current or wind, will always be set up the same way. Plane traveled 435 miles each way to San Salvador and back. The trip there was with the wind. It took 3 hours. The trip back was into the wind. It took 5 hours. Find the speed of the plane in still air and the speed of the wind. So the airplane speed I'm looking for, and wind speed I am looking for. And you can use x and y, I don't care, as long as you tell me what your variables are. So my rate then with the wind means that the airplane is going to be helped by the wind. And the time there is 3 hours. And that is going to equal my distance. And then on the way back was into the wind or against it. That means the wind is going to be working against me. That should always take longer, by the way. That's just a little clue. If you're flying against the wind and you can assume the airplane's doing the same thing it was doing before, this should be a longer time. It should take you more time to do that if that is the same distance, which is what these are. So those are your equations. I go ahead and divide out that 3. So I'm going to go ahead and divide that 3 out, and I'm going to divide that 5 out, okay? So I will be left with just the a plus w, and I'm going to divide this guy by 3. All right. And then on the second equation, I'm going to left with a minus w, and I'm going to divide out that 5. All right. And then I have the perfect equation for elimination, right? So I am ready to just go ahead and add these because my w's are naturally going to cancel. So I have a, and a gives me 2a. My w's will cancel. This is going to give me, what, 232? And then I'm just dividing by 2 at that point. So I found the wind speed. It is 116 miles per hour. To find the wind, I'm just going to plug it back into either one of these. A minus W, 116 minus the wind equals 87, right? Or I could plug it in here, 116 plus the wind equals 145. It doesn't matter. Whichever way I do it, just make sure you divide out that negative when you do it. You're going to get the same answer. So you're going to get that the wind is going 29 miles an hour. The school is selling tickets. So what you're looking for is two variables. On the first day, they sold 9 senior citizen and 4 student. There are your variables. So you want to set up an X and a Y for these. X is going to be my senior citizen. Y can be my student, right? So once you know what your two things are that you're talking about, you can start setting up your equations. They sold 9 senior citizen, that's 9X. And they sold 4 student, that is 4Y. The total, if you add them together, is 102. Then you should have a second one. $120. Well, that is the total from the second day. 9 senior citizen, that's 9X. And 10 student, that's 10Y. Now I can solve by elimination. Now, you have to check. They will not automatically eliminate, right? Because I have a 9 and a 9, but one is not negative. So I do need to multiply one of those equations by a negative before I add them. And then once I do that, I am ready to add. My negative 9 and positive 9 will cancel. My negative 4 and positive 10 will give me a 6Y. And my negative 102 and positive 20 will give me 18. And then I can just divide both sides by 6 and get Y equals 3. That tells me that my student tickets cost $3. And then you can go back and just plug that in. 9X plus 10 times Y equals 120. Solve for it. And once you solve, you will see that your senior citizen cost $10. And you have your answers. So you will have inequalities. You will have to graph inequalities and you will have to write the equation for inequalities, okay? So you will have them in slope-intercept form, like the first one that I have up here, and in standard form, like the second one. Slope-intercept form, you're ready to go. You're going to start at your y-intercept here. That's positive 2. My slope is 1. You do have to decide for these, is this solid or dashed? So this one in particular is solid because it is an or equal to. So I'm going to make that line solid. And you do have to decide how you're going to shade. For this particular one, it is greater than or equal to. So I'm going to find that y and decide where it's bigger. It's bigger up here. So I'm going to shade above it. My second line, I'm ready to graph. So I'm going to go to my y-intercept here, positive 6. Going up 5 will actually take me off the graph. So I'm actually going to go down 5. It's a positive slope, though. So if I go 1, 2, 3, 4, 5 down, I should go left 1. And so that's going to put me right here. Again, is it solid or dashed? Well, I'm going to look at that greater than equal to sign. It is solid because it is or equal to. And so I am going to make this a solid line. And then I'm going to decide where to shade it. It is less than, so I'm going to say, well, where is less than? Well, it's this side of the line. So I'm actually going to shade everything on this side of the line. And then you're going to say, where do they cross? Where they cross in this wedge. And this wedge is what is actually your answer right there. You can darken it like I did there, as long as I can tell that's your answer, right? Lightly shade until you know what it is. Or you're welcome to not shade at all and then just figure it out all at once. I mean, as long as this final answer is shaded, you are good to go. So you don't necessarily have to show me this part of it, but you need to be very specific about what your answer is. If you look at the next page, these are all in standard form. You do want to move them over to slope-intercept form because it can change your greater than, less than. So if we look at this first one here, I need to move that x over. So I have negative 4y equals, or not equals, is greater than negative x plus 28. And then I have to divide everything by negative 4, which actually causes my sign to flip. All right. So for this particular one, it flipped my sign from greater than to less than. From greater than to less than. And so I can graph that. Negative 7, that's right here. Positive 1/4, that's going to be up 1 over 1. And then just like the other one, is it solid or dashed? Well, this one is dashed because it is not an or equal to. So I'm going to make this one dashed. And then where do I shade? Well, I have to look at my final one like this to decide where I shade. Here it is less than, so I'm going to shade underneath it. So this is where the shading would be for this one. And then I'm going to do the same thing using my second equation. So for the second equation, I'm going to move that over, move that 3x over. I'll have negative 2y is less than or equal to negative 3x plus 4. And then I am going to divide everything by negative 2. Y, and now this sign flips again, greater than or equal to positive 3/2 x minus 2. And so I'm going to start at negative 2. And you can go down and left, or you can go up and right. It doesn't matter which one. Solid or dashed. This particular one is solid because it is or equal to. And then where am I shading? Well, this is greater than. So I'm actually shading everything above this line, which is up here. And you'll see this little tiny bit where they cross. So it crosses right here, this little wedge down here is where it crosses. So just like you graphed it, you now have to tell me what it is. So let's walk through this. Let's talk about the first one. We'll do this one. I always start with my y-intercept. My y-intercept for that line is where?
2.
At 2. Positive 2 or negative 2? Positive 2. So I'm going to put my plus 2 right there. And then I'm going to find my slope. What's the slope of this line that I put that red dot on? Positive or negative? Positive. So I'm going to find another point. We'll say this one up here. Okay? And so then I'm going to walk it, and I'm going to say, well, that went up 1, 2, 3, and over 1. 3 over 1. So that is a slope of 3. So I have the line. Now I just have to figure out where they shaded it. So here's my y. Did they shade this line above it or below it? Below it, right? Nothing shaded right here. You can see that. We're talking about this line right here. Above it would actually be on this side of it, wouldn't it? Yeah. Below it is on this side of it. So they shaded below it. Is it or equal to?
No.
It is not. How do I know?
It's dark.
It's dashed. So I have this first line. I'm done. I'm going to do the same thing for the second. My y-intercept is at positive 4. My slope is going to be positive or negative?
Negative.
Negative. Here's a point, here's a point, here's a point, right? Down 1 over 1. You can see we're going down 1 over 1, which is a negative 1x. You can write it like this, or you're welcome to write the 1. And then once again, did they shade above this line or below this line? They shaded above this line, right? So this one is going to be greater than and not or equal to because, again, it is dashed. That is my answer. I'm done.